A scientist from Switzerland named Fritz Zwicky made an observation that shook the entire field of astrophysics. He was looking through a telescope at a large galactic cluster called the Coma Cluster. It is a collection of thousands of galaxies located hundreds of millions of light-years away. Zwicky noted something astonishing there. He measured the speed and movement of the galaxies, and the result was completely unexpected. According to calculations, those galaxies were moving so fast that they should have flown out of the cluster. That is, they should have drifted apart from each other. But in reality, they were all held together as if something was binding them strongly. The principle of science is very simple. The more mass there is, the greater the gravity will be. But the problem was that the matter we could see, stars, gas, galaxies, could not produce enough gravity to keep this system intact. This means there was some invisible mass present that was holding everything together. Zwicky gave it a name, dark matter, which means something that exists but cannot be seen. At that time, the scientific community did not take this idea seriously. People thought it was a miscalculation or overly imaginative thinking. Zwicky's style was also harsh, so he was not taken seriously, and this theory was almost forgotten. In the 1970s, a scientist named Vera Rubin revisited the same problem, but in a different way. She measured the rotation of stars within galaxies. Logically, stars near the center should move faster and those at the edges should move slower. But what she observed was the opposite. Stars at the edges of galaxies were moving at the same speed as the stars in the center. It was as if some hidden force was holding the entire galaxy together. When all these observations were combined, a startling fact emerged. About 15% of the universe is what we can see, and the remaining 85% is something we cannot see, and this is dark matter. After that, experiments started worldwide. Underground laboratories were built, sensitive detectors installed, particle accelerators used, all with one goal: to directly detect this mysterious matter somehow. But every time the outcome was the same: silence. In science, two main ideas emerged. First, WIMPs, or weakly interacting massive particles, very heavy but weakly interacting particles. The second were axions, very light and extremely elusive particles. Today we focus on the WIMP theory. In the universe, everything has an opposite, called an antiparticle. If both meet, they annihilate each other and convert into energy. Scientists think that maybe dark matter particles similarly annihilate each other, releasing special energy. And this energy might be detected by us in the form of gamma rays. If this theory is correct, we should find these signals there, at the edges of galaxies, dark matter halos, or places with high concentrations of matter. But the problem is that there are already numerous gamma ray sources in the universe, making it almost impossible to distinguish the real signal. Now, in the modern era, scientists are reanalyzing new data, especially gamma rays coming from space. In some observations, a strange pattern has been seen: light spread in a faint glow as if an invisible structure is present around the galaxy. Is this really the first shadow of dark matter, or is it just a coincidence that we are misunderstanding? This question remains open. In science, nothing becomes reality until it is repeatedly proven in various ways, and this is where the debate of 2025 was not just about a discovery but had become a question about the fate of an entire theory. Scientists were no longer just checking if a signal was found or not. They were trying to understand where else in the universe the effects of dark matter should be visible if it really exists. Because if this unknown matter is as abundant as estimated, then it should not just be at the center of galaxies but everywhere gravity plays its part, and this was the new thinking. And during this period, telescopes and detectors around the world began viewing the sky in a new way. Data from the new powerful observatory in Chile was capturing images of billions of galaxies every night, and in every image, scientists were trying to find a hidden pattern that points toward this unknown matter. Because if dark matter really exists, it cannot be limited to gamma rays only. It must also influence the movement of stars, as if a hidden hand is holding the entire galaxy from within. And this was the moment when another astonishing fact began to emerge. The motion of galaxies was not just in simple orbits, but their outer edges were rotating as if there was extra mass present there. And this was the old question that Fritz Zwicky had raised nearly a century ago. But the difference now was that behind the question was data thousands of times more extensive, and the machines were much more sensitive. Yet the answer was still incomplete, because every time scientists thought they were close, some new noise again made the signal doubtful. Then another astonishing idea emerged. Maybe dark matter is not something out there but a property of our own dimension that we cannot see under normal conditions, just like a two-dimensional being cannot understand a third dimension. Similarly, it is possible that we live inside a reality most of which is completely invisible to our senses, and we can only see a small part of it which seems like the entire reality to us. Vera Rubin Observatory. The new data arriving each night was either strengthening old ideas or completely breaking them apart, but no one could yet claim that dark matter had truly been captured. Because with every possible signal, there was also an alternative explanation, and this is what turns the whole story into a scientific mystery, not a simple discovery. Because here every answer raises three new questions and every piece of evidence sparks a new debate. Then comes a moment when science not only seeks answers but begins to question its own foundations. If this really exists, then why haven't we found it yet? And if it does not exist, then what is the cause of all these observations leading us towards it? This is the point where humans begin to see the universe not just as a machine but as a kind of mystery with every answer containing another hidden question. And perhaps this is the real truth toward which all this research is pointing, that the more we know, the more we realize that we know nothing. And the story does not end here because the main question still remains. If dark matter really exists around us, will we ever be able to see it directly? Or will it always remain a shadow that controls everything but never reveals itself?